So today we're going to be talking about intermolecular forces. And essentially, an intermolecular force is what keeps molecules together. It's what attracts one molecule to another. That is very different than an intramolecular force. So if you remember when we talked about intramolecular forces, those were the attractive forces within molecules. So my attractive force is going to be what attracts one water molecule to another. The intramolecular force is what attracts that hydrogen to the oxygen in a water bond. There's three main different types of intermolecular forces. And the first type is a London dispersion force. You'll also hear them called van der Waals. And they are going to occur because of the movement of electrons in an atom. So as those electrons move, they start to cause what is called a dipole, so just a little momentary movement of electrons, and that is what's going to cause our van der Waals. So if you look at the picture down here, these molecules are the same, the electrons are just going back and forth, and so that's going to cause our little momentary movement of electrons. They are going to occur with all molecules and atoms. So even N2, which is completely the same, two nitrogen atoms, they're going to have London dispersion forces as well that are going to make those because of the electrons moving back and forth. In that box it says other. Our other info is that they are going to increase in strength with an increase in molar mass. So the higher your molar mass is, the stronger your van der Waal force is. As far as their strength, they are very weak. They're the weakest force we are going to talk about. And a picture of a London dispersion force would be something like this. So we have two hydrogens, they're equal strength, yet their electrons are moving back and forth, causing that little momentary van der Waal. Next up, we have a dipole-dipole force. So dipole-dipole is an attraction between oppositely charged regions of a polar molecule. Basically what that means is we have a polar molecule, and so the opposite regions of the polar molecule, the positive and the negative, are attracting here. These will only occur with polar molecules. So in order to have a dipole-dipole force, we have to have a polar molecule. And they are going to be stronger when our molecules are closer together. So the closer in proximity those polar molecules are, the stronger their dipole-dipole force. They're medium in strength. And if you look at this picture, HCl, we have a positive and a negative end. And so they are going to have a dipole-dipole attraction. And then the final type is a hydrogen bond. Hydrogen bonds happen when one atom of hydrogen is highly attracted to a very electronegative atom, like nitrogen, oxygen, or fluorine. So in order for these to happen, we have to have hydrogen and we have to have nitrogen, oxygen, or fluorine. It's important to point out here that hydrogen bonding isn't a bond. It's just called that because it's an extremely strong attraction. So it's going to happen with extremely strong polar bonds, and therefore we're going to have this really strong force of attraction. For your other info, big keynote, it's not a chemical bond. So the word bond throws people off sometimes, but this is just a really strong attraction. They are the strongest force, which is why they're called hydrogen bonding. And if we look at a picture of these, in order to have a hydrogen bond, we have to have nitrogen, oxygen, or fluorine. So that's how we could depict this from the rest. As far as determining what type of intermolecular force you have, there's a few questions you want to ask yourself. So first question is, does it have hydrogen in it? And the answer is no or yes. So if it does not have hydrogen in it, then you're going to ask yourself, is it polar? No or yes. If you do have hydrogen in your molecule, but you don't have nitrogen, oxygen, or fluorine, then you are going to be a polar molecule, or then you're going to go back to this polar question. And if you do have one of those, then it'll lead you to a type of bond. So if you don't have hydrogen and you're not polar, then you are a London dispersion force. If you do have hydrogen, or you don't, but you're polar, then you're a dipole-dipole. And if you do have hydrogen and you have nitrogen, oxygen, or fluorine, then you are going to be a hydrogen bond. So we're going to determine the type of IMF for these 3 types of bonds. In order to do this, we're going to need the Lewis dot diagram. So figure out the Lewis dot diagram and then figure out the polarity from that, which you would need to know the Vesper shape from. And then once you do that, you can figure out the type of IMF. So for our first one, in Cl3, if you draw out the Lewis dot diagram, nitrogen has a lone pair on the center. And so that is going to be a trigonal pyramidal shape. And then when you figure out your trigonal pyramidal, you will figure out that you're polar. And polar means that we will have a dipole-dipole force. We would also have everything underneath it, so a London dispersion force would also be present. For CH4, that's a tetrahedral shape. Tetrahedral shapes are almost always nonpolar. So this is a nonpolar bond, and so that means we're going to have a dispersion force. And then the final one, HF, we do have hydrogen with our fluorine, so we don't have to do any Lewis dot diagrams to figure out that hydrogen bonding is the type of IMF present there.